Hello everyone, welcome back to my channel CyberXPopsy. In this video, we're gonna discover Advent of Cyber 2025 Day 18. The Day 18 we're gonna discover about the ICS Modbus class for concern. I think ICS basically stands for Industrial Control Systems. Let's step onto the room and we'll discover what are the challenges they have given for us. As you can see, learn to identify and exploit the weaknesses in ICS systems. Just want to be a quick disclaimer. Since I'm new to the cybersecurity, I may not able to cover in depth of the components they have given in TryHackMe for this room. So we'll make this very concise. And if I miss anything, any component or explained in a wrong way, just make sure to comment. I'll try to rectify the mistake. So let's move to the task one, which is the introduction. So after going through my understanding, what I have discovered from the story is the TBFC drone system is hacked. So instead of Christmas gifts, drones are delivering chocolate eggs. Someone called King Malheur has changed the system logic. So our main job is to investigate the PLC and find what's wrong inside and fix it safely. This is the story what I have understood, and we'll move to they have given some mystery discovery. So I think this might be helpful in later stages. So for now, once when we start the attack box, we'll try to save this in a text and we'll continue. And these are the learning objectives for this room. So how's SCADA, which is supervisory control and data acquisition systems, monitor industrial processes, and what are the PLCs do in automation. So PLCs is a programmable logic controllers, and how the Modbus protocol enable the communication between industrial devices, and how to identify compromised systems configurations in industrial systems, and the techniques for safely remediating compromised control systems, and will understand the protection mechanisms and trap the logic in ICS systems. And as usual, we're gonna set up our environment provided they try hack me. So we'll start both try attack box and a target machine at the same time. And it will take time to machine to boot up. So we'll answer this question. The clock is ticking, investigator, Christmas is hanging by a thread, and you only can pull it back from the break. So as you can see, both my attacker machine and target machine, the status has been in the green signal. So I'm gonna check for the time being, and we'll continue when the machine is boot up complete. So we'll minimize, or we can use the full screen, and we'll minimize the attack box. And we'll move to the task 2. So the task 2, they have given the in-depth explanation of SCADA. So I don't want to go in detail. So if you want, you can go through it. So I'll just explain my understanding what SCADA is. So SCADA is like the brain and the eyes of factory. So it monitors sensors, control machines and logs and everything. And there are some key components of SCADA when it comes to sensors. So they just read things like weight or position, and the actuators which move things like robotic arms, and the PLC which is programmable logic controllers. What they do is like they are like small industrial computers that make quick decisions. And there are some monitoring systems like CCTV on dashboards will show what's happening. And last but not least, the historians, which where we store the logs. And they have given how the SCADA works in the drone delivery system. You can go through it. And in concise, what I understood from SCADA is of the TBFC, SCADA controls drones, packages, types, delivery zones, and safety systems. So attackers basically love the SCADA because it uses the old software, so it can easily trick, and it has often default storage, I mean like default passwords, and it mainly focuses on reliability, not security. So, and it also uses Modbus, so which has no authentication, so it is very security loophole. And it has asked, so we'll answer this question. What port is commonly used by Modbus TCP? And they have given 502, and it should be 502. So let's go and we'll check this. And this is the task 2 about the SCADA. So I would highly recommend to go through in detail, and we'll move to the task 3, which is PLC and Modbus control. While talking about PLC, which is a programmable logic control, it is a super tough industrial computer. So because it runs 24 by 7 and talks directly to sensors and motors. So Modbus is the protocol of PLC which is used to communicate. It's simple but it is not secure. Anyone who can reach port 502 can read or write values. So that's the reason we have earlier they have the question, and they have some Modbus also have some data types. For example, they have given a type which is a coil which is 0 or 1, which basically stands for whether the motor is running on or off. And also they have given holding registries where the values can you can read and write, and the input registries just to read only sensor values, for example taking a current temperature or a pressure reading and the flow rate. But in our system, when it comes to this lab, we're gonna use basically this, and which about HR0, which is package selection type, and HR1 delivery zone, and HR4 system signature. And the coil controlling behavior will, once when we do the practical task, we'll go through this. And it also give a Modbus addressing, and you can go through this. And if you have any, as we discussed before, Modbus has no security problem, because since it didn't have any no authentication, no encryption, no authorization, no integrity checking. And connecting to the dots, now you understand why the OpenPLC web interface shows nothing useful. So that's the reason King Malheur bypassed it entirely. He connected directly the Modbus TCP port and manipulated the registries and calls that control the system and behavior. That note you found, the maintenance technician must have discovered what's happening and started documented the compromise values. The warning at the bottom never changed the HR01 wishlist C11 equals to true. We'll find out. So just they figured out the trap mechanism before getting interrupted. So in the next task, we'll use Python and the PyModBus to investigate the system exactly the way King Malheur attacked by directly reading and writing Modbus values. Time to see what he actually changed. Let's see. And King Malheur basically entered into the TCP port using 502 and change and compromise the system. So we need to get back to its original state. And for now, you have understand how the system works. The mission is yours. Hack it back and save the Christmas. Okay, we'll check it. I'll move and we will move to the task 4, which is the practical part. So here I perform the nmap, which is followed by SV, the version, and the ports. Here are 2280.502 and my IP address. This is the result I got, and we can come to know that our through nmap the ports are open 22, 80, and 502. These are the ports we are looking for. This exercise, our main thing is to look after 80 and 502. So we came to know that since CCTV has been compromised, we need to ensure and check into the browser whether it actually compromised or not. We'll copy and we'll open the Mozilla Firefox, and we'll go, and I have already pasted this one. As you can see the status, which is compromised and disarmed. So with this we can see there are colored eggs being sorted and Easter theme packaging on assembly line, and the delivery drones are loading eggs instead of gifts. So while looking at this CCTV, it clearly shows that the warehouse is loading Easter eggs, confirming an attack. So instead of eggs, here has to be gifts. So now we need to come back to its original state. So for that, we need to connect to the PLC and use PyModBus. So we're gonna use Modbus investigation. So first we need to connect to the PLC using Python and the PyModBus library. Let's go, and if you are using your own machine, try to install PyModBus. Since I'm using an attacker box, it is already installed, and they have given this command how to connect to the PLC. And or for now we will connect to the connect. I will see. and we'll use Python, and we'll use Python, Control Shift V. Okay, as you can see, the connection has been failed. So how we gonna do is, that's the thing. First we need to enter Python and install, then we need to enter, okay, my bad. First we'll open the terminal and we use Python 3. See, I think this one I don't think so. We don't need to use, so here only we can use Control L. So we're gonna use Python 3. And then here we're gonna enter our script. So this is the script I'm looking. So what you're gonna do is, so obey Control C, and I will try to paste the script over here so that I don't need to go again and again. And here, so we're gonna open a new file and use this one. Yes, so I have already saved this document to connect to the PLC. So there is already a script, so I'll Control C. First the thing is we need to enter into the Python, so Python 3, enter. Now we can use Control Shift V, and let's see, enter, enter. Oh, why? Here we need to give the machine IP. Forgot, shit. Okay, so here the machine IP address is I forgot to give the machine IP address, and you can see my machine IP address is this. That's the reason. We'll copy this and over here, and we'll try to paste here so that I can Control Shift V or Control V. Yeah, and now I should able to connect. Control C and Control Shift V and enter. Yeah, now we have successfully able to connect to the PC, and we did the first step. Now we have connection to the PLC Modbus interface. Now notice how authentication was required. This is very critical security weakness in the Modbus protocol. So it doesn't have any authentication. So that's what it's stating. And we'll move to the step 3, which is reading holding registers. Holding registers store numeric configuration values. According to the note, HR0 controls the packet selection. Let's read it. Okay, so I have the second script. So which is this? We're gonna Control C and chill. Yep, this is the one I'm talking. Control C, and now we're gonna paste this one. Control Shift V, and let's see, execute. And it says HRZ01. So HRZ01, as I earlier mentioned, which means the chocolate eggs. So it indicates the holding register indicates the chocolate eggs. That's all we got. And there it is. So HR0 is set to 1, which means the system is configured loaded to chocolate eggs. That's what we already know registered. And the note was right. This is exactly what's the causing the problem. Let's check the HR1 delivery zone. Similarly, we'll check the delivery zone, and the script for that is this, and Control C, and again here Control Shift V, and should able to execute now. Enter, enter, and it says HR1 the delivery zone is 5, and it indicates normal delivery zone. Over here, well, let's check to the map again. Info, where is the map? As you can see, the delivery zone, if it is 1 to 9, it is normal, and 10, which indicates the ocean dump. And that's all we got, and which indicates the zone 5 is normal. Now let's check HR4, the system signature. let's go to the HR4, which indicates the system signature. If the default is 100, that's okay. Current we'll need to check. Let's see. Again, we'll copy the script. We did this one, we already did this one. Now we need to check the system signature. We'll copy this, Control C, and here Control Shift V, enter, enter. Yeah, it says the King malware signature has been detected and exploited detected. That's what we want to know. If it is a normal, it should be like default, and but the current has been detected as exploited detected, which is King malware signature. That's all we found through the web browser as well. You can see this is the one I'm talking, and we'll minimize, and then we'll go over here, and they have given the signature 666, and we also got the signature as 666, and the value 666 confirms the system has been compromised by the exploit framework. This matches the taunt message we saw earlier, exploit version 6.666. Okay, now we'll move to the step 4, which we'll read the calls. Calls are boolean flags that control system behavior. The note mentioned several critical calls. Let's read them. Okay, and if we go over here, coils and inventory system, if it is true, system checks the actual stock, and if it is false, the blind operation. Okay, we'll go to our the script, and we'll go to coil, we'll read the coil, so we'll again copy this, Control C, and we here, and we will do Control Shift V. As you can see, enter, enter, and you can see, so it is disabled. It indicates the inventory verification has been false and the system not checking the stock. That result, the hacker is trying to exploit the system, which is the compromise the website. And integration verification has been disabled. The system is blindly following the commands without checking the items that actually exist in the stock. That's what the people are receiving the eggs instead of gifts. And we'll go to the next coil, which is the protection override. Let's see, and we'll read the protection override first of all, and if there is true, the changes locked monitor, and if it is false, the normal operation has to be saved. Okay, we'll go to the script, and this is the protection override, Control C and Control Shift V, and then and then yeah, it says even though the protection override has been true, the actions are it is active, the changes are being monitored. So this is crucial. C11 is enabled, which means the system is actively monitoring for changes. Remember the warning on the note, never change HR0 obviously C11 is true will trigger a countdown. Even though it means like even though it is active, so we don't need to overwrite anything over here. Now let's check the self destruct, it is already armed. Okay, we'll copy the script, read coil 15, so this is the one I'm talking. We'll copy, Control C, and again Control Shift V, and let's enter, and it says not armed, safe for now. Okay, good news, the self destruction isn't armed yet, but it will be if we try to change to HR0. So if we change to HR0, even though if it is even though C11 is still active, this is the trap for the mechanism. So now we need to understand the trap. So now node makes complete sense. The maintenance technician discovered HR0 is set to 1, which is forcing the X, and C11 protection is enabled, monitoring for changes, and if anyone changes HR0, C11 is true, C15 gets armed. So that's the one we actually we found that. So yeah, this is the one. So just make sure if we overwritten, it will be armed, even though if it is not armed. If we change this one, the C11, the C15 will automatically armed. So it's going to be very complicated to get back to its original. So this technician warning has was trying to say whoever found this note making the things works. So we'll complete the reconnaissance script. Let's create a comprehensive script uh, to see the full state and exit the Python interpreter. Okay, now we need to exit this first, and we'll exit. I think we'll minimize this as well. Exit ex. Okay, we'll exit the Python interpreter. So we'll exit, and we got this, and we'll clear Control L. So now we'll get a plain thing. Now we need to perform the next stage, uh, which we need to do instead of there are different options we can do step by step whatever the things, but however that's not main challenge for this call. So we'll create a whole comprehensive script there since they have already created. So you can use any text editor. I'm gonna use Pluma, so it would be very easy. Pluma recon.py. So since it is a Python script, I'm gonna use it as py.py, and let's see. And now it's saved as and we'll copy this whole thing. They're doing some changes. If you want to do, you can go through the script and Control C, and here Control V. We need to save. Let's see. We will minimize this for a time being. As you can see, if I save it as py, it's changing the text. So save. I think a file save as I don't know where it's saved. For the time being, I want to save it on the desktop, and yeah, save. And we got, we'll minimize, and let's see, we got the, yeah, this is also the one I'm looking for, recon.py, and we got the text. Now we need to interpret the script, so we need to run the script using python 3 and run the script. So we'll use python 3 and recon.py. Okay, so it has given, when we run the script, it shows the holding registers, which we already checked, and we already checked the delivery zone, which we did earlier, and HR also this one we have also found that the signature has been rejected and the calls boolean flags were false, and that should be true. And C11 we don't need to do any changes over here, and C12 I don't think so. And it says the threat assessment is all about, it's about the exploit frame was detected by king malware and protection mechanism is active and the trap is set, so we don't need to fall for the trap. And package type force to X, and lastly inventory verification disable. We need to make sure what is going inside the warehouse. So earlier we noticed that here instead of X there has to be gift, so we need to return to the gift. So audit logging is also disabled. This is also very crucial, so it says remediation is required. So okay, and now we have a complete picture of the compromise. It's time to restore the system. So based on our reconnaissance, we need to disable the protection C11 first and change the package type to Christmas gifts HR0 to 0. It has before 1. That's the reason we are forcing the X. And enable the inventory verification, which is C10 equal to true, and also we need to enable the logit and also verify the C15 never get armed. So the order is critical. If we change the HR01 before disabling 11, the trap triggers. So we'll create a remediation script. So again, I'm gonna use Pluma now. So we know this for now. We can control L, and now we're gonna use Pluma, and we can use restore recon. Okay, restore whatever you want. Restore recon.py again. And now we're gonna copy the whole script. We need to make sure, Control C, here Control Shift V or Control V, as you can see, and now Control S, and now save as. We're gonna save it on the desktop again. Restore. Now we want to save it on desktop. Save, and it is saved, and we can close this. Uh, Cancel. I don't think so. We will minimize maybe. So now we'll try to use Python 3 restore recon.py, and it's verifying the system and package type, which is moved to the X now, and the protection is active, and disabling the protection mechanism. Protection is still disabled and safe to proceed with changes, and setting the package type to Christmas presents, and package type change it to Christmas presents now. Before it was supposed to be X. And now step 4, enabling the inventory verification, what's going inside the warehouse. And the step 5 is enabling the audit, so whatever, if there are any changes, it will be logged. And lastly, the verification system restoration, the package type has been set to the 0, which is a Christmas, and the gifts have been restored to the true, and the emergency dump, I don't think we didn't do this. And finally, we made a Christmas, that is saved. Christmas deliveries have been restored, and drones will now deliver presents, not eggs. Check the CCTV to see the results. So we'll check the CCTV. As you can see, the system has restored, and the King Malhar was not happy now. And finally, we have made it back to its original state, and it is disconnected. We got some flags, so we will copy this. Control C and Control V. And we got this. The Before submitting the flag, we'll ensure the post-incident analysis. That's what we sophisticated what the King malware, because firstly the mod access, the where the King malware is entered to the port 502, and they manipulated the configuration values directly at the protocol level, and they disabled the safety mechanisms. We did this, and every time whatever goes in has to be locked. And audit can be used for the several purposes after post incident analysis, and left a signature 666 as a calling card where we did at the initial recon stage. The maintenance technician who left a note likely discovered the compromised bus interpreted but before they could fix it. The documentation saved the Christmas by warning about the trap mechanism. Yes, they did. And congratulations, you have finally successfully investigated and remediated an industrial control system compromise. Now you have learned how SCADA system works, and how PLC operated, and how Modbus communication function works, and mostly how attackers can manipulate the systems, and how to safely remote the restore. And we will submit the flag now, and we'll check. And voila, we have finally able to solve the flag. And if you enjoyed today's room, feel free to check out for OT challenge and another room industrial intrusion. I would highly recommend to go through that room and gain some knowledge. And we are finally about to wrapping up this video. And once and like, we'll check this. And congrats, we have finally able to complete this room. ICS, which is Industrial Control Systems, Modbus Claus for concern. And that's all for this video. I'll wrap it up, and I'll see you in the next video. Until then, take care. Signing off, CyberX Popsy. Happy hacking.